a battery? A battery is a container containing one or more electrochemical cells. Electrochemical cells convert chemical energy into electrical energy. Inside each lithium polymer battery are smaller batteries called cells. Electrical current travels to each of the cells within a lithium polymer battery via conductive surfaces. Each cell consists of layers of conductive material, allowing for the charge and discharge of ions. Just like other batteries, there is a positive cathode and a negative anode on each side of the cell. The cathode, which is the positive electrode, is made out of a pure lithium metal oxide. The more uniform its chemical composition, the better the performance and the life of the battery is going to be. The anode, which is the negative electrode, is made out of graphite. In between there is a transport medium called an electrolyte, which allows the battery's lithium ions carrying the charge of the battery to flow freely. The electrolyte is made out of a very pure material, as free of water as possible. In between the two electrodes, a permeable separator is placed to prevent short circuit. However, its permeable qualities, specifically called microporosity, allow for the ions in the battery to travel from the positive to the negative side.
The lithium polymer battery is similar to the lithium ion battery. The only difference between the two is that the separator is a flexible microporous polymer in the lithium polymer battery rather than the static separator with holes for ions to flow through in the lithium ion battery. During discharge, lithium is oxidized, which means it loses electrons. The electrons and the ions flow from the negative electrode to the positive electrode, creating a current which can be used to power a load in a circuit. During charge, lithium ions migrate towards the negative electrode, where they store electrons from an external energy source, which could be DC current from a charger. Properties of lithium polymer batteries. Lithium is the lightest metal, as you could see from the periodic table of elements on the right. It contains a great electrical density, as you could see from the table on the left. And it contains thin cells which allow it to fit in most devices. And its separator is a polymer which allows it to be flexible. The properties of lithium polymer batteries make it an ideal battery for a variety of applications, such as RC helicopters for its lightweight, mobile phones for its slim structure, cars, laptops, etc. Advances in lithium polymer batteries can lead to thinner, flexibly shaped, decreased weight, and high capacity devices and products such as flexible phones. Lithium polymer batteries can be dangerous if not handled correctly. It may lead to explosion and endanger the user of the device. Many safety rules are put in place so the battery does not explode because of an incorrect charging voltage. Lithium polymer batteries deteriorate over time, leading to a small lifespan of 1 to 3 years in most mobile devices, which is a con for lithium polymer batteries.
Environmental benefits of lithium. Lithium polymer batteries uses in electric and hybrid vehicles has provided a significant reduction of CO2 emissions caused by gas-powered vehicles. Also, the use of these batteries has also aided in preserving the world's remaining fossil fuels, as they are quickly running out, and they also provide an alternative source of fuel and energy for many different purposes. Environmental impacts of lithium. Due to the high demand of lithium in the growing technology world, it is constantly being mined and imported from countries such as Bolivia, Chile, China, and Argentina. Lithium is found in salt flats in areas where water is very scarce and it requires large amounts of water to be mined. Also, toxic chemicals are used for leaching purposes, and these chemicals require waste treatment afterwards, and there are widespread concerns for improper handling and spilled around the world, just like any other mining operation. Also, water contamination and transportation depletes the quality of the elemental lithium used to make these batteries. The recovery rate of lithium polymer batteries, even in first world countries, is extremely low. Almost all the batteries end up in a landfill and can never be reused again.